Hello everyone, welcome to my channel. So today I'm here in front of you with the second video of projectile motion. In the first video, I have discussed about the introduction of projectile motion. That means what do you mean by projectile motion? What are the assumptions for projectile motion? That means we actually derive some basic formulas in case of projectile motion. What were the formulas? The formulas were the formula for the time of flight, the formula for the maximum height, and formula for the horizontal range. So this was the motion of a projectile, and these are the formulas. Okay, so T, H, and R, these three formulas are very important. You have to memorize this formula. Okay, so today my target is to explain the path of the trajectory. That means, as you can see that from the point O, we have actually thrown a football or a projectile, okay, and the projectile follow a particular path, this one. So today actually our target is to discuss or explain what is the nature of the path or what is the trajectory. Okay, we will discuss this one, but before discussing the path, we will solve one simple numerical related to this topic. After that we are going to discuss that one. Okay, so you can see the question that I have written the question here. So you can see that a ball is thrown from a field. Okay, suppose this is the field and a ball is thrown. This is the ball with a speed of 12 meter per second. So the ball is thrown with a speed of 12 meter per second. That means this is your u, the initial velocity. So you can write u is equal to 12 meter per second, right, at an angle of 45 degrees. So this is your theta, right? So theta is 45 degree with the horizontal. That means this is your u is 12, and this angle is your theta, that is 45 degree. The question is with okay, at what distance will it hit the field again? That means distance. So the question is, demand of the question is, you have to find out the distance. So simply the ball, when it is thrown from this point, suppose this point is O, it will follow this path and it will hit the field again at this point. Okay, so obviously the question is about the horizontal range. So you have to calculate simply R. Now how you can calculate? So the formula you have for the range. So first of all, you write the formula. What is the formula? U square sine 2 theta by g. This is your formula for horizontal range. And now you have to put the values. Okay, this is simple formula putting math. So the value of u is 12 square sine 2 theta. That means sine 2 into 45 degree, and the g, in question g is given as 10, so you can take g 10. So 12 square, that means 144. Sine 2 into 45, that means sine 90 degree. You know the value of sine 90 degree is 1, so you can put the value of sine 90 degree 1 and 10. So you are getting 14.4 and unit is meter. This is your answer. So this is a simple question from the projectile motion. Okay, okay, okay. Then after that, this is the simple question. So you have from the by using the formulas we can solve this type of question. Now before discussing the path, that is our aim, I will just simply tell you some 2 points related to the range. Okay, after that we will actually derive the equation of the path. So we have the range. The formula for range is u square sine 2 theta by g. This is the formula for range. Now my question is that for what value of theta the range is maximum. That means you can see, you know that at the time of javelin throw, what the athletes actually do, they are throwing the javelin at a particular angle with some particular initial velocity. Okay, so suppose your initial velocity is fixed and u is constant, but you have to throw your javelin at a certain angle such that it actually hit the ground at a maximum range. Okay, that means your target is, you have to find out the maximum range of the projectile for a particular angle theta. Okay, now how we can do this? So before that, you know, if that from the math, if you know that if y is a function of x, okay, that means y actually depends on x, then the value of y will be maximum or minimum. When, for what value of x? We can find out that value of x by first order differentiation of y, and after that we will equal the dy dx with 0. Okay, that means the first order by doing the first order derivative equal to 0, we can get the value of that particular x for which y is maximum or minimum. Okay, so by doing this we will get the value of x. Now the maximum or minimum, whether it is maximum or whether it is minimum, you can get by again the differentiating this one, that means by getting the second order derivative. If it becomes positive, then your value will be minimum, and if it becomes negative, then your value will be maximum. So simply we can get that value of x for which y is maximum or minimum, or simply maximum, by just simply doing the first order derivative, calculating the dy dx and equate it to 0. So in this case again this thing is simple. We have to calculate the maximum range. Now how can we calculate the maximum range? By actually uh, okay, sorry, by differentiating the range with respect to theta. Simply, and we will equate this one with equal to 0. So you have d theta. What is our u square sine 2 theta by g is equal to 0. So in your case, u square and g is constant. So we can take this 2 out of the differentiation part. So we have d theta sine 2 theta equals to 0. Now, you know the differentiation. We know that dx of sine x, you will get this as cos x. Okay, and if the differentiation is like that, if dx sine ax, if a is a constant, then we can actually write the answer as ddx, sorry, ddx of sine x is cos ax, like that. So simply sine 2 theta, that means 2 cos 2 theta is equal to 0. This is your differentiation. Now u is constant, g is constant, 2 is constant, that means this cannot be 0. That means simply cos 2 theta is equal to 0. And we know cos, if for what value of theta, cos theta 2 theta is 0, cos 90 degree, so, or cos pi by 2, and so 2 theta is equal to 90 degree and your theta is equal to 45 degree. So for theta is equal to 45 degree, the range will be maximum. Okay, this is a simple question. It may come in your school level exam, or in MCQ directly you will get the that for what value of theta the range will be maximum, and some 4 options are given, so you will get you know the what will be the answer. And in case of derivation part for school exam, you have to derive all these things. Okay, this is the first portion from the range. And now the second point which we have to know, that I'm going to explain now. So this is the formula for range. So you simply know that in this case, if this is your initial velocity u, this is your theta, then this is your range. You know this one. Now suppose u is constant. U is constant. The value is of u is same. Now if the theta, suppose that theta is now different, that means in case of theta the formula is this, and now you will calculate the value of range, the formula for range for an angle 90 minus theta. Okay, the different angle. So how we can do this? So again we get the formula r is equal to u square sine. Now in this case, in place of theta we will write 90 minus theta by g, right? So u square sine 90 into 2 means 180 degree minus 2 theta by g, u square by g. Sine 180 minus 2 theta means how we can calculate this? So sine 180 means this is 90, this is your 90. So, and minus 2 theta, that means you are in the second quadrant, right? So because this is 2 into 90, that means sine will remain sine 2 theta, and because after calculation we are getting that the point is in the second quadrant, and we know all sine tan cos, that means in the second quadrant sine is positive, that means you will get the positive sign here. So the formula is actually similar to the previous one, right? The answer is same. So simply you can say that if the value of initial velocity is constant, you will get the same range for two different angles. One is for theta and other one is 90 minus theta. For this two value of angle of projection, the answer of the range of the projectile will be same. Okay, these are the two things you have to memorize. Now the next part, actually the main important thing which I will discuss today, that is the path of the projectile. Okay, so what is a path? For this, okay, let me discuss it in more detail. So this is y axis, this is x axis, and this is your the path of the projectile, this one, and this is your initial velocity, this is your theta. Now, if we want to derive the path of the projectile, that means the equation for the trajectory. Actually, we are going to derive the equation of trajectory. That means equation of the path, right? So how we can do this? Actually, equation, when we are want to derive some equation of the path, that means in the along this axis y and the x, that means we will get a equation in which we will have actually y and x, that means equation in terms of y and x. This will give you the path of the trajectory. Okay, now how we can derive this? Okay, again, the same thing at the time of discussing or at the time of derivation of something related to the projectile motion, we will actually calculate with two axes separately. That means for x and y axis. So in the last video, I have discussed that in case of x axis, the initial velocity is u cos theta, and in this case u sine theta. The acceleration is 0, and in this case acceleration is minus g. Okay, now let us suppose the particle, the projectile is thrown with an initial velocity o at a certain angle theta, and now at a certain time t, suppose the projectile, actually the position of the projectile is this one. This is the position of the projectile after a certain time small t. Okay, after a certain time small t. Now at this moment, what is the value of the, that means the x coordinate will be x and y coordinate will be y. So in this case, the height of the projectile from the ground is y and this distance is x. This is clear? Okay. Now for the x axis, if I want to calculate x, so we will use s is equal to ut plus half at square. For the x axis, can I write this one, uxt plus half axt square? Okay, now ax is 0, that means this portion is equal to 0. So what is ax? Sx is equal to x. What is ux? Ux is equal to u cos theta. What is t? We have taken the time as t. This is not the total time. Okay, this is not equal to the time of flight. It is a random position. We are actually taking the value of position is this one, and the coordinates are x and y. Okay, so from this you can get t is equal to x by u cos theta. This is your formula, right? Now this is the time taken by the projectile to reach from O to this position T, suppose. Now you will calculate, you will actually do the calculation for the y-axis. So in case of y-axis, again you can use the formula S is equal to ut plus half at square. And now for the y-axis, you will put sy, uy, ay, this one. And time will be same, obviously. In time t, the projectile will reach to the point P and y coordinate will be y. That time is fixed. So Sy is equal to capital small y. Obviously, it will be positive because it is in the upward direction, is equal to, what is uy? Uy is u sine theta. We can put this one. What is t? T is equal to x by u cos theta plus half ay is minus g. Again, t is x by u cos theta square. It is clear? Okay. Now y is equal to u and u will cancel out. So x sine theta by cos theta, that means x tan theta minus half g, okay, x square by u square cos square theta. Okay, this is the path of the equation. Okay, equation of the trajectory. Now you can see that y, actually left hand side you have y, and in the right hand side you have actually the sum. These are the constant sum, but x is the power of x is x square, and you know from the first chapter, that means for in the beginning of the class 11, there's a mathematical tools. That means some portion is there in which some equations are given. That means, you know, if the equation is y is equal to mx plus c, that means the equation will be that is, you have y or x, that means graph will be a straight line, right? Okay, if it is c, that means there is a intercept, this one. So again, if your equation is y is equal to 4ax square like this, okay, or y square is equal to 4x like that one, then you know that the equation between y and x will be parabola. Okay, that means the path will be parabolic. So simply if you compare this one with this equation, so you can see that in the one part the formula the value is y, and in the another part some square is there. That means this is your parabolic path. That means the equation of trajectory is actually similar to a parabola. So you can say that the path of the projectile will be parabolic in nature. Okay, so this is actually from the equation of trajectory. So simply this is the derivation. You have to do these derivations for your exams. Okay, and for the competitive exam you have to memorize the formula. Clear? Okay, so this is all about from this from this video. Now in the next part I will actually I will actually give you some important previous year questions from the NEET exam, or different type of questions which are actually very much important to actually clear the concept of projectile motion. Okay, so the next video actually will be actually mainly it is based on the numerical portion. Clear? Okay, that is for today. Thank you.